Hey everybody, it's Mr. Carr again. Today we're talking about 2B, solving multi-step equations, but we're also going to be putting variables on both sides now. Before we did our multi-step equations, variables were on just one side of the equation. Okay, today we're going to have both sides. All right, so again, like a quick reminder, we have done problems with multi-step ones, but that was only on one side. Sometimes we combine x's together or y's or whatever, and then solve from there. Okay, now we're going to have variables on both sides. And another thing we're going to cover today is identifying the number of solutions an equation has. Okay, so keep in mind, when solving, always put the variable terms on one side and the constant terms on the other. Okay, so when I talk about variable terms, I'm talking about things like these. 2x is a variable. Okay, and when we go future, we'll have two variables at a time. I might do 3a plus 4b. Those are variable terms. Maybe I do smiley face, -5 smiley face, or frowny face, or whatever. Bottom line is we are representing numbers with these variables. Okay. Constant terms are numbers. Okay. So 25, -13 and 4. Okay, these are constant terms. So the goal when I deal with variables on both sides is to get all the variables on one side and get all the constants on the other. So I look down here, we got 6 examples to go through. Okay, so when I do this, again, your preference might be different from mine. I personally like dealing with positive variable terms. So what I like to notice is that 4 is smaller than 9. So I'm actually going to subtract 4a to both sides as my first step here. Okay, so if I do that, I get 15 is equal to 5a minus 5. Now the goal was to get all the constant terms to the other side. So I'm going to put 5 over here. So it gives me 20 is equal to 5a. And you might do this as a single step or like at one level instead of taking it 2 times like this, but I'm just showing you all of my steps. Finally, I'm going to divide by 5 so that I get a is equal to 4. And I kind of switched the order. I guess officially I did this. I did 4 is equal to a. But it's the same thing if I go the other way. For number 2, remember, if I have t showing up multiple times, I have to distribute here. So 4t minus 12 is equal to 6t plus 18. From there, again, 4 is smaller than 6, so I like doing it this way. Some people like to always put the variables on the left side, and that's totally fine too. You just sometimes just deal with negative values. So I get -12 is equal to 2t plus 18. The only other things to combine would be the -12 and the 18. So I'm going to subtract 18 to the other side. So that's going to give me, I'll just rewrite it up here. Not a lot of space. Sorry about that. That's going to give me a -30 is equal to 2t. Now I'll divide both sides by 2, so I get -15 is equal to t. Okay. Number 3, 5 is bigger than 3k, so I'm going to subtract 3k over. So 2 plus 2k equals a -6. Subtract the 2 over to the other side then, so that 2k equals a -8. Divide by 2, and I get k equals -4. Every time I've done this, I've make sure to get all my variables to one side and my constants to the other. All right. Again, same thing here. I have to distribute because I've got m on both sides of the equation. So 6 times 5m is 30m. 6 times a -3 is a -18. 1/3 times 24 is going to give me 8m. 1/3 times 12 is going to give me a 4. I like bringing the 8 this way. Okay, so we subtract 8m to both sides. So I get, that'll be 22m minus 18 is equal to a +4. Then I'm going to add 18 over. Oops. Okay, so that 22m is equal to 22. Now I can divide both sides by 22, and I get m equal to 1. All right. 5 and 6, we're going to go ahead. I like bringing the 3a over here. So that's going to give me 6a minus 6 equal to 7. Now I can add 6 to both sides, so that's 6a equals 13. divide by 6, and you notice that it's not a whole number. It's just going to stay a fraction of 13 over 6, and I can't simplify it. I've heard this from students before. Oh, am I supposed to get fractions? Yeah, they're fine. Nothing wrong with fractions. Fractions are fun. Okay. So now on number 6, I'm going to distribute the 3. So 3 minus 9x. Distribute the 2. So at negative 8x plus 14. Again, I like to bring the bigger one over to try to make a positive. So I'm going to bring 9x over this way. So that 3 is equal to a positive 1x plus 14. And then I'll subtract 14 over. So that I get a negative 11 for x. Okay. These are not the only way to do these problems. My preference every time has been to try to make my x variables positive. Okay. It's not always going to be possible, but that's just my goal usually. Identifying solutions. That's our last skill for today. So identifying solutions is going to tell us how many solutions we get, and you're going to see some certain patterns show up. So for example, if I try to do this like I normally would, I'm going to distribute the 4 here. Then I'm going to bring my x's to one side, but you notice something there. I've now canceled out 4x on both sides. And if I do that, I end up getting 5 equals 20. So here's a weird thing. When is 5 equal to 20? Never. 5 does not equal 20. So hopefully you understand that. This right here means does not equal. So 5 does not equal 20, meaning this is actually going to be a no solutions. And what that means is if I try to plug in a number for x here and here, I'm never going to find something that works. Okay, nothing will ever be able to plug in there that actually gets me to work this out to both sides being equal. So that means no solutions, which we sometimes show as that, a circle with a slash through it. So that's one scenario we look for. We might get no solutions. Here, if I distribute, I get 6x minus 3 equals 6x minus 3. You can maybe see something that's interesting here, but if I subtract 6x over, those cancel out, and I get negative 3 equals a negative 3. Well, when is this true? Always. Okay. This is always true that negative 3 equals negative 3. Anytime you get a number equal to itself, okay, that means it does not matter what I put in for x. Just for the fun of it, I'm going to plug in, let's say, x equals 1 and x equals 2 here. So if I do 6 times 1 minus 3, does that equal to 3 times 2 times 1 minus 1? So 6 times 1 is 6 minus 3 here. On this side, I've got 2 times 1 is 2. And then 2 minus 1 is 1. 6 minus 3 here is going to give me 3. 3 times 1 is 3. Hey, that checks out. I plug in 2. 6 times 2 minus 3. Does that equal to 3 times 2 times 2 minus 1? So 6 times 2 is 12 minus 3. 2 times 2 is 4. And then 4 minus 1 is going to give me 3 there. 12 minus 3 is 9. 3 times 3 is 9. I have the same, like both of these numbers worked in this equation. What this means is I have infinitely many solutions. Oops. Bring that back, I guess. There we go. Infinitely many solutions. Okay. No matter what that means is no matter what I plug in for x, I could pick any number I want, any decimal, any negative number, anything that can go in there, it will work out to a true statement in the end. Okay. So there's infinitely many solutions. So we have 3 possibilities for identifying solutions. We have one solution, which is what we've dealt with so far. We found a value that is representing that variable. We could have no solutions, or we can have many solutions. Those are our 3 possibilities here. One, none, and many. Okay, and that's really what it boils down to is how do we identify that? False statement is no solution. True statement is infinitely many. And sometimes you still get one solution. So we're going to try this one out. 5 is distributed, so I get 5x plus 5 is equal to, this will be distributed there, 15x minus 12, and then minus 10x. We can put these together here, so I get 5x plus 5 equals 5x minus 12. And you might recognize right now that it's what it's going to be. But I'm still going to subtract 5x over. Though both cancel out, I get 5 does not equal negative 12. So my answer here is no solution. And my final example here, I'm going to distribute the 3 here. 6b minus 3 minus 7 equals 6b. 6b minus 10. Okay, I'll put these together. So I get 6b minus 10 equals 6b minus 10. Hey, you might notice again, a little bit of a shortcut, but if I subtract 6b over, I get negative 10 equal to negative 10. That is a true statement. So it is infinitely many solutions. Okay, so again, 2 things we covered today. What happens when we have variables on both sides of the equation? We bring them together on one side and the constants to the other, and then we can solve from there. The other thing we looked at is the number of solutions. Possibilities are 1 solution, which we've done a lot with, but then there's also no solutions and infinitely many solutions. Okay, and that's it for today. All right, I will talk to you again on this one. Take care, everybody. Oops. Okay.